This is Unit 7, Objective 7. We're at the end of the unit, and maybe you've noticed throughout this unit that sometimes we write the parabola in a certain way, but then other times the parabola, the equation, is presented in another way. Unit 7 is just all about maybe you have to go from one form to the other, which is going to involve completing the square. But the biggest question I get at this point in time is, I know how to do it, I just don't know when I need to do it. When do I need to do it? And the answer is this. If it's a parabola, if you can look at the equation and you know what the vertex is simply by looking at the equation, then you're not going to have any completing of the square to do. Same thing with the circle. If you can look at the equation of the circle and you know where the center is, then you're not going to have to complete a square. So let's take example number 1. We have this equation. If you look at its characteristics, y is to the first power, but x is being squared. So you know it's either going to be an up or a down parabola. Now, we're just going to go through the motions of getting the y by itself, getting it into y equals form. So the first thing I'm going to do is I'm going to move the x minus 2 squared over to the other side of the equation. So I would have 8 times y plus 5 equals, now when this moves over there, it would move with a subtraction sign, so this would be negative on this side, x minus 2 squared. So I've just learned something else about this parabola. It's actually going to be a down parabola because of that negative. Now, let's worry about the leading coefficient. We got to get rid of that 8. So one of the things you might think of is I'm going to divide both sides by 8. You could do that, but the other thing to do would be multiply both sides by 1/8. So now I'd have y plus 5 equals, I'm going to keep the negative there, but I'm going to introduce the 1/8, and then I'd have the x minus 2 squared. I'm really now only one step away from having the parabola written in y equals form. So y equals, and all I have to do is take that positive 5 and tack it on to the end back there with a negative 5. Negative 1/8 x minus 2 squared minus 5. So that's actually the equation I'm going to use from now on, because now there are going to come some questions. First of all, what's the vertex of the parabola? And we know the vertex of the parabola is positive 2, negative 5. But if you go back to the equation as it was originally given, we knew that. Positive 2, opposite of what's in the parentheses, negative 5, opposite of what's in the parentheses. So we knew the vertex was positive 2, negative 5 from the very beginning. That's why we didn't have to complete the square. So now let me mark positive 2, negative 5. Okay, so my vertex is somewhere about right there. Positive 2, negative 5. Now, I also know it's a down parabola because of the negative, and I also know that it's a rather wide parabola because of the 1/8. So I'm going to make a down wide parabola. So, there's a decent representation of this parabola. I'm going to make it a little bit more decent. Okay, that's a little better, not a whole lot. But anyway, that's the parabola. Now, the next thing we need to know is the directrix and the focus. Both of those are dependent on the C value. C equals 1 over 4 times the A value. And in this case, the A value is negative 1/8. So we've just got some math to do. C equals 1 over 4 times negative 1/8. So C equals 1 over 4 times negative 1 is negative 4 over 8, which equals 1 over, that would be negative 1/2, which equals 1 over negative 1/2 is negative 2. So C equals negative 2. Now remember, the negative simply is the direction you need to go to find the focus. And we know you have to go down because it's a down parabola. So if I'm at 2, negative 5, and I go down 2 steps to find the focus. Well, when you travel vertically, you change the y-axis. You don't change the x-axis. So this would be 2, negative 7. So the focus would be at 2, negative 7. Now we're going to take that same C value and we're going to go the other way to find the directrix. So I'm going to take 2 steps up to find the directrix. Remember, that's a line. It's not just a point. It's an entire line. And we want to know, what would that line be? Well, if I was at negative 5 and I went up 2, I would be now at negative 3. So y equals negative 3. So the directrix is y equals negative 3. Now we want to know the focal chord endpoints. If I went from the focus and came over here and hit the parabola, and then I came over here and hit the parabola, what would those points be? Okay, well, that depends on 2C. Well, if C is negative 2, then 2C would be, I'm just going to call it positive 4, not negative 4, because remember, it's just a distance. So if I was at 2, negative 7, and I went 4 units to the left, when I travel left and right, it's the x coordinate that changes. So if I'm at 2 and I go 4 units to the left, I'm now at negative 2. Negative 7. The y unit doesn't change. Now, if I'm at 2, negative 7, and I travel 4 units to the right, I'm now at 6, negative 7. So those would be my focal chord endpoints. Now, the last thing the problem asks is, well, the graph is going to tell you how many x-intercepts. You can just look. How many times does this parabola cross the x-axis? 0. How many y-intercepts? Again, the graph tells you there is one y-intercept. It crosses the y-axis once. Okay, for example 2, one thing that we've got going for us in our favor on example 2 is the equation is already written as x equals all of this. So I already know just by looking at the equation that it's going to be either a left or a right parabola because that's what x equals does. Now, if I look at the leading coefficient of y squared and I see a positive 2, that even tells me something more. It means it is specifically going to be going to the right. So I know just by looking at this equation, it's going to be a right parabola. But there's a lot that I don't know about this parabola. By looking at the equation, you can't pick out the vertex simply by looking at the equation. So it's not in descriptive form, which means we need to complete the square. Because that's what it always comes down to. If you can see the vertex simply by looking at the equation, you don't need to complete the square. If you can't, then you do need to complete the square. So the first thing I'm going to do is I'm going to send the 99 over to the other side. So x minus 99 equals 2y squared plus 16y. Now here's where I need to complete the square, and since it has a leading coefficient of 2, I'm going to have to factor the 2 out, so the y squared is by itself. So x minus 99 equals, now factor out the 2, and you're going to be left with y squared plus 8y. And I need that third missing term, so I'm going to put plus blank, and that's where I'm going to complete the square. So half of 8 is 4. 4 squared is 16. So on the right-hand side, I'm using the number 16 to complete the square. But because of the leading coefficient of 2, I don't add 16. I add 16 times 2, which is 32 to the left-hand side to keep the equation all in balance. Now, at this point, I'm at x minus 67 equals, I've got that leading coefficient of 2, and I've got my perfect square of y plus 4. Because remember, it's always that 1/2 number that makes the perfect square. Y plus 4. Now I'm almost at x equals. All I've got to do is add the 67 back, move the 67 over to the other side, and I've got x equals leading coefficient of 2, y plus 4, quantity squared plus 67. Now that's my equation in descriptive form. And that's going to help me with the rest of the problem. I can now see exactly where the vertex is simply by looking at the equation. My y-coordinate of the vertex is -4, opposite of what's in the parentheses, same as what isn't, 67. So 67 -4 is my vertex. So what I'm going to do here is, I don't have grid lines on this. I'm just going to say this is 67 right there, and then I'm going to go down 1, 2, 3, 4. So there's my vertex. And remember, from the very beginning, we knew this was a right parabola because of the way the equation is set up. You can see it here too. That's a positive 2. So the parabola opens to the right. Now, we have to find the focal point, which we know is inside here someplace. And we have to find the directrix, which we know runs in back of the parabola. Now, both of those things depend on the C value. So C equals 1 over 4A. That's the formula that's going to help you with this. So that equals 1 over 4, and the a value is 2. It's the leading coefficient, 4 times 2. So that makes the c value simply 1 over 8. C equals 1 over 8. Now, what that means is I need to take 1/8 of a step to the right to find the focus. Well, if this is the vertex at 67, -4, going to the right 1/8 of a step, when you go left and right, the only thing that changes is the x-coordinate. So if I was at 67 and I went 1/8 of a step further to the right, I'd be at 67 and 1/8. My y-coordinate didn't change. I'm still at -4. So that's the focus. Now, I go the exact same distance the other way. So if I'm at 67, -4, I'm back at the vertex, 67, -4, and I go 1/8 of a step to the left. Well, that's just going to subtract 1/8 from the 67, and I'm going to be at 66 and 7/8. And remember, the directrix is not a point, it's an entire line. In this case, it's a vertical line. So that vertical line would be x equals 66 and 7/8. Now, the next thing I need to worry about are, what are my focal chord endpoints? What would that point be right there? And what would that point be right there? What would those 2 points be? Well, they depend on the value of 2c. So if c equals 1/8, then 2c would equal 2/8, which we know as 1/4. So 2c equals 1/4. Now, to get to the focal chord endpoints, we start at the focus, which was this, 67 and 1/8, comma, -4. And this time we travel down 1/4, and we travel up 1/4. Well, when you travel up and down, you affect the y-coordinate. So one of the focal chord endpoints, the one that would be if we went down, would be at 67 and 1/8. Okay. Now, if I'm at -4 and I drop another 1/4, I'd be at -4 and 1/4. Now, the other one would be if we went up. So if we were at 67 and 1/8, comma, -4, if I go up, my x-coordinate hasn't changed, but my y-coordinate has. If I'm at -4 and I add 1/4, I'm at -3 and 3/4. And now the last thing I have to do is simply answer the questions, and the graph tells me everything I need to know. How many x-intercepts does this particular parabola have? Well, if we go back and look at the graph, you know eventually this side of the parabola will cross the x-axis. So 1. And how many y-intercepts does this parabola have? Well, this parabola is never going to cross that y-axis. So the answer is 0. For example 3, there's something we already know about the parabola in example 3 by looking at the equation. We know y is to the first power. We know on the other side of the equal sign, x is being squared, and it has a negative leading coefficient. So I already know simply by looking at this equation that it's going to be a down parabola. However, the test is, can you identify the vertex simply by looking at the equation? And the answer is no, you can't. So we know we need to complete the square. Now the nice thing is the constant is already over here on the left-hand side with the y. If it were over here, we'd have had to have moved it, but it's already over here. So I just start the process of completing the square. Y plus 40 equals, I'm going to factor out that negative 1 that's in front of the x squared, and I'm actually going to put the 1 there. You could just put the negative sign if you want, but it is a negative 1. When you factor out a negative 1, the x squared turns positive, but the plus 24x becomes a minus 24x, and then we have to complete the square. So, half of negative 24 is negative 12. Negative 12 squared is positive 144. But because of that negative 1, it isn't positive 144 that I'm going to use to balance the equation. It's a negative 144. 144 times negative 1 is negative 144. Now the next step would just be, let's take a look at what we've got right now. We have 40 minus 144 is negative 104. So y minus 104 equals, I'm going to keep that negative 1 there, but I know I created a perfect square by completing the square, and that perfect square is x minus 12. So now all I'm going to do is move the 104 back to the other side, and now I have y equals negative 1 x minus 12 quantity squared, but when this moves over here, it would be a plus 104. Now I know a lot of things about this parabola. I knew all along it was going to be a down parabola. Well, now I have it in descriptive form, so I know for sure that leading coefficient right there, the a value, is negative 1. But I also know the vertex. The vertex of this parabola is at positive 12, 104. So I'm going to put where I think positive 12, 104 would be. I'm just going to call it somewhere about right there. That's 12, 12, and then 104 up. Okay, so this is 12, 104. Now, we also know this is a down parabola, so it does something like this. And so we know there would be a focus on the inside, and there would be a directrix on the outside. We just have to figure out those locations. And both of those locations are dependent on the c value. C equals 1 over 4a. My a value in this problem is simply the leading coefficient of negative 1. So c equals 1 over 4 times negative 1, which would be 1 over negative 4, which is negative 1/4. So c equals negative 1/4. Now the negative is simply an indication of the direction to go to find the focus. So we have to go down to get inside of the parabola and find the focus. So let's go back to the vertex. If my vertex was at 12, 104, and I take a quarter of a step down, well, when you travel up and down, the only coordinate that changes is the y coordinate. So I know the focus has an x coordinate of 12. but what's the y coordinate? Well, if I was at 104 and I dropped 1/4 of a step, I'm now at 103 3/4. Now the directrix uses that same 1/4 of a step, but it goes up. So if I was at 104 and I went up 1/4 of a step, I would be at 104 1/4. And the directrix isn't a point, it's an entire line, so it's y equals. Now, the focal chord endpoints, well, they depend on 2c. Well, if c is negative 1/4, then 2 times negative 1/4. 2 times negative 1 is negative 2, so negative 2/4, which is negative 1/2. So 2c would equal, I'm going to drop the negative because all that is, it's a distance. Distances are never negative. So 2c equals 1/2. So I'm going to find the focus, which was 102, 103 3/4. And I'm going to go a half a step to the right and a half a step to the left to find those focal chord endpoints. Well, when you travel left and right, the only coordinate that changes is the x-coordinate. So I already know the y-coordinates of my focal chord endpoints are not going to change. They're 103 3/4. The big question is, what are the x-coordinates? Well, if I was at 12 and I took a half a step to the left, I'd be at 11 1/2. Let's put ourselves back at 12 again and take a half a step to the right. Well, that would be 12 1/2. And there are our focal chord endpoints. Now, the only thing left is to look at the parabola and answer these problems. How many times is this parabola going to cross the x-axis? And the answer is 2. How many times is it going to cross the y-axis? And the answer is 1. Okay, enough with parabolas. Example 4 takes us back to a circle. When we look at the equation, I know for a fact it's a circle because x is squared and y is squared. But the old litmus test is, when you look at this equation, can you identify the center? And the answer is no. So we know we have to complete the square. So we're just going to start the process of completing the square. I'm going to group my x's, and I'm going to make room for the third part of the trinomial. So x squared plus 12x plus the third missing number. I'm going to do the exact same thing with the y's. Plus y squared minus 4y, and then make room for the third number. Now, the constant moves over to the other side, so that positive 21, when it moves over, will be negative 21. But remember, I'm going to be adding the sum of those two missing numbers. So let's start completing the square. Half of 12 is 6. 6 squared is 36. Half of negative 4 is negative 2. Negative 2 squared is positive 4. So 36 and 4 on this side are the equivalent of 40 on that side. So now, what are my squares? My perfect square that I just created for the x's is x plus 6. Now, the perfect square that I just created for the y's is y minus 2. And over here on the right-hand side, negative 21 plus 40 is positive 19. And so there's my equation. So what's the center of the circle? Negative 6, positive 2. Now, what's the radius? Square root 19. Now, if you didn't have a calculator, we're going to ask you to sketch this. So if you don't have a calculator, here's what you can do. Square root 19 is somewhere between square root 16, which is 4, and square root 25, which is 5. So think of square root 19 as somewhere around 4.5 steps. Okay, more than 4, but less than 5. So more than 4 steps, but less than 5. Now you might be wondering, why are we doing that? Because you're going to be asked to sketch the circle and identify the number of x-intercepts and y-intercepts. Well, we know the center is at negative 6, 2. So let's go negative 1, 2, 3, 4, 5, 6, 1, 2. Let's say that's the center right there. Now, what's the radius? Well, it's more than 4 steps, but it's less than 5. So if this was negative 6 and I go more than 4 but less than 5, I don't reach all the way over there, because it would take 6 steps for me just to hit the y-axis. So I'm going to go more than 4 but less than 5 that way. I'm going to go more than 4 but less than 5 that way. I'm going to try to go the same, more than 4 but less than 5 that way, more than 4 but less than 5. Now remember, this is only a y value of 2. So if I take 4 steps, 2 gets me right there, and then I take 2 more on the other side. And this is hopefully a decent representation of that circle. And now you can answer the question of the intercepts. How many times does this touch the x-axis? Twice. Once right here and once over there. But how many times does it touch the y-axis? It never touches the y-axis.